So I'll start. So about me, I'm the head of application security at Yaya Finance. Prior to that, I was a security researcher at a few different places. And then before that, I was just a regular Java developer. So this talk started, well, the idea for this talk started quite a long time ago. I found two relatively minor CVEs in a Java framework called Toggles, XSS and CSRF. Nothing that amazing about them. But the Toggles framework implements a design pattern called feature toggles. And what that does is allows you to deploy to production code, and then once it's deployed to production, you can enable and disable it dynamically, or enable it for certain users based on like IP ranges. So certain users from this geographic area get routed to the new code, and others get routed to the old code, or by a percentage, or lots of different ways you could do it using this Toggles console. One of them, which became very interesting to me, was that you can execute it. You can write JavaScript embedded in the JVM and use that to decide whether that feature toggle is enabled for that web request or not. And so that's why it's JavaScript. It is run inside the Java JVM using the Nashorn scripting engine, which at that time existed. It was deprecated in Java 14, I think it was. Anyway, so using those two vulnerabilities, exploiting in the real world, where normally it'd be deployed onto the server in production behind some sort of authentication, or it would be enabled, maybe not with authentication, but on like an internal service. And so how you would kind of access that functionality, especially the Java scripting functionality to gain remote code execution, was something I was looking at. It was difficult, though. You have to effectively know the name of the toggle to be able to access it. And so you could do like a CSRF attack if you against it, but you would have to have like insider knowledge already. So realistically, it would be actually hard to pull off an attack using this. But I worked with the team at the time to fix the vulnerabilities. They were all fixed, and yeah, that was all fine, but it kept bugging me. And around the same time, I read a paper about how certain companies, eBay was one of the big ones, that was using a fingerprinting technique where they would essentially do a port scan using JavaScript in the browser to port scan your local network and localhost and use that for like fingerprinting you to work out who you are. This worked because even though normally you can't make a request from ebay.com, a JavaScript loader from ebay.com to localhost, you can under certain circumstances. With the big caveat being that you can't read the response. But you can do a port scan if you base it on timing. So if that port is closed, it will, even though you won't be able to read the response, you'll get a response out very quickly. If it's closed, if it's open, it'll take longer, and you can use that to work out which ports on your local machine or your local network are available. They don't do this anymore, but at that time they did. So to do this, you need what are called simple requests. These are requests that essentially don't trigger a pre-flight to the underlying server. To do this, it's quite limited. Only head, get, post, a few content types, no auth, no cookies, so you can't have an authorization header. So any kind of authentication that's enabled on that service would essentially block this kind of request. So yeah, quite limited, and no status. You don't get the status code back. You don't get any data back from the server, but the server is the HTTP endpoint on that server is triggered. It's just that the JavaScript running in your browser isn't able to see it. So this is what the kind of request looks like. If you're interested, very simple. In Firefox, you get the request, you don't get a response. In Chrome, you get an error, but the effect is the same. And so what you would normally see with more standard request that wasn't simple, you'd get a pre-flight to whatever that service was, and based on the response back, it would then allow you to do the request you actually wanted. Simple requests just happen, but you don't get to read the response. So, using this as a starting point, I worked out a way the toggles endpoint was able to be accessed via a simple request. And so, by writing some JavaScript, putting on an external website, which looks like this, you can then edit one of those toggles and run that script. This is it's JavaScript, but it can access any Java classes or methods in the JVM. You can execute essentially any arbitrary code you want. And you might be able to work out what's going to happen if you can read that. But yeah, it's so hopefully if I swap displays, do I? No. Okay, so this is what it looks like. It's going to start up a simple Spring application with the toggles console. This is what the toggles console looks like, by the way, in case anyone's interested. You can set up feature toggles, an activation strategy, all of that. Lots of different kind of strategies you can use, but of course the one we really care about is the Java scripting API. As you can see, nothing here. But run it, and we should see that the calculator gets popped up because the request went to localhost, triggered the toggle endpoint, and added the JavaScript and executed it. And you can see that's what it looks like. So, and now I have to flip it over again. Okay, sorry about that. Okay. Okay, so that works, but as an actual attack, it's very limited. Effectively, you have to know the name of the feature toggle you want to inject that code to for it to work. So again, in the real world, very difficult to pull off. The best way I could think of was to create a tutorial website. You would download the code containing the feature toggles that I knew about, and the website, the tutorial website would have JavaScript running in the background, completely silently. Unless you look at the development console, you don't see anything, but it will keep running, and then you can execute remote code on the development machine. So that was the first one, but this is not. That wasn't limited to that single framework. This is effectively a very common kind of design pattern of when bound to localhost, no one bothers with authentication or any sort of protections against that API because it's bound to localhost. Why bother? And so from there, I found some more. So Spring actuators. This is part of the Spring framework, which is the most popular Java web framework out there. In early versions of Spring, you were able to perform, actually some of them you can still do it, but they have lots of actuators. Some of them are relatively benign, even in deployed production, like health, which is like a health check endpoint. Some less benign when deployed to production, but generally speaking, most people wouldn't expect them when deployed just to the developer environment for that to be an issue. So we can take a look at some of them. Again, so you're able to do shutdowns. You can restart the developer's local version of the application they're building, which will annoy them, but again, not necessarily the worst thing in the world. This still works in the latest version of Java, by the way. In the latest version of Spring. What I'll show you next is unfortunately limited to Spring 1. But there was also remote code execution from some of these actuators. You had to have Spring Boot 1, which is now end of life and has been for quite a while. And you had to have a few extra dependencies like Spring Cloud, which allows you to modify, which enabled the /env actuator to not just read environment variables and properties within the application, but write to them. And that's how you then get remote code execution. So, if we take a look. This is what the payload looks like. So what you're able to do with this /env actuator is make a post request to it. Once you're able to modify properties within an application and restart the application, there's going to be lots of ways you can get RCE on the application. This is the one I use, and I'll then use it in a few others later on, basically the same technique. But there will be others. It's just the one I found was easiest for me. And so what's happening here is we're modifying the database URL that this application will connect to, modifying it to use the H2 database, which is a Java in-memory database, which has an interesting function which we'll utilize in a moment. And what this will be doing is, on startup, it will then create an in-memory database, and as part of the startup of that in-memory database, it will be pulling a SQL file from wherever I want it to, which will contain the underlying payload. This is what the payload will look like. So I'll explain this a bit because I will be using this again later on. This is an in-memory database called H2. It's mostly used for testing, but can be used in production as well. It's for testing, it's used because as a developer, you may not necessarily want to have a full-blown database running on a local machine. If you're just doing some like integration tests or unit tests, you may just want to have like a nice, quick in-memory database you can bring up. So as long as that's on the class path, you're able to do this. And the H2 database has a function called alias. And you might be able to read that this doesn't look like regular SQL. And so what this does, the alias function in H2, I don't think other databases have a similar thing, but maybe they do. It allows you to compile and execute arbitrary Java code. And so that's what this does. We're creating an alias called shell exec, which essentially is just going to run a command, whatever we then pass in. And then we're calling it, open up the calculator app. But yeah, it's interesting function in the H2 database. So, front one toggles, then Spring, a few issues in Spring. Then went to other frameworks. So this is Quarkus, which is Spring-like framework built by Red Hat. It's their version of Spring, effectively. If you know anything about Spring, this should look pretty familiar to you. This is just a HTTP endpoint. Yeah, very Spring-like. But anyway, they have an interesting feature, which is a developer UI. So when you're building your application, if you run it in developer mode, it will bring up a developer UI, which you can then use to modify the application, get information about the underlying application, lots of stuff like that. And again, it's got a nice fixed path. So from an attacker's point of view, as long as you know that that developer is probably using Quarkus, there's a good chance that this would work at the time anyway. Obviously, this has been fixed. So again, similar attack in Spring. We're modifying the database URL and sending this is a class as a simple request, so you're able to make this request from the web browser silently, hits localhost, and you can modify the JDBC URL, and from there, bring back code execution. So, and by the way, all of these demos and the payloads are available. There'll be a link at the end of the talk if anyone's interested. So it's just spinning up the Quarkus application in developer mode. This is the nice developer UI that you get. You can get lots of different. There's lots of different features. You can get environment variables. You can get lots of other stuff. But we want to look at the config editor. So this already has a JDBC URL, but we want to change it. And by the way, this was an unmodified demo Quarkus application from the official Quick Start guide. I pulled down and was able to run this on, so it didn't require any real extra kind of custom work to get the attack to happen. So this is what the payload will look like, and what the JavaScript looks like from the web page will be running. Very similar. Essentially, it's the same as the Spring one. We'll be modifying the JDBC URL, throwing in the payload, and it should then pop a calculator. But yeah, it's an interesting function in H2. I really don't know why they've added it. There must be some reason, but it's, especially if you get just SQL injection on the H2 database, you can easily go from there to remote code execution. So yeah. And you can't see it now. Anyway, okay, so you may have missed most of it, but went to the web page, popped up the calculator app. Interesting that it also modifies the underlying properties of the application on disk as well. But as you can see, we've been able to execute code silently on the developer's machine. Cool. Okay. So I told the Red Hat security team about this. It took a while for them to kind of understand what the problem was. I don't think this is like a normal kind of vulnerability they would get. But once they kind of got it, their CV was issued, and it's still the highest CVSS score in Quarkus. So from there, lots more. MLflow, which is a machine learning training developer environment. Again, has a nice UI, deployed to on localhost port 5000 this time. This is a bit different because it's a REST API and uses JSON, and that's not one of the content types that are allowed for simple requests. However, that doesn't stop you, because like a lot of APIs, they don't bother checking the content type. So you're able to, even though it's JSON, the post request contains JSON, doesn't mean the content type has to be that. A lot of the time, web servers don't bother checking. So from there, with MLflow, you have an interesting way you can attack it. Unlike, you don't get remote code execution. Well, actually, there are ways you can. But the one good thing you can do with this is the training data that you're training your machine learning algorithm on, you can exfiltrate it, essentially. You just change the default location of the training data to be an S3 bucket you control. Make sure it's like publicly writable, and make this request, and then you can exfiltrate all that data. And that's what it looks like once the attack has occurred. It's some pain to set up the S3 bucket, so I'm not going to do that now, but that's what it looks like. And again, the other thing you can do, because this is a Python application and it serializes the data, the training data, you can also get remote code execution via like a Python pickle deserialization attack, because you control the data once it's put to the S3 bucket, you just modify it, and when it's loaded up again, you can do what you want then. So, one more thing. This is the rest of the stuff I've talked about before. This is actually the first time this has been made public. So, MCP, Model Context Protocol. We always got to have some sort of AI stuff nowadays. So, it's MCP. It's a protocol created by Anthropic last year, I think it was, and it allows LLM agents to interact with resources. So, if you have like GitHub Copilot, Claude Desktop, Klein, lots of different agents, the way they're able to say access your file system or access a resource on the internet is using an MCP server. These MCP servers, there's a set protocol. There's a client that sits within the LLM agent, and that then, based on what you ask it, it will then decide whether to use what's called a tool, which is just a HTTP endpoint inside of the MCP server. So whatever you ask it, it has a list of endpoints, and based on what it decides, it may then decide to trigger that endpoint, read the response, and then use that in its kind of thinking. Or use it to influence the outside world. So you can read data, but also those endpoints can do stuff, like write to a file system. There's a few ways you can do the communication between the MCP client and server, but one is HTTP, server-side events, and it always uses JSON RPC as the content type. So this is what the request is meant to look like. So you get, first of all, the client makes a HTTP request to the /SSE endpoint. Connection is left open, and it returns a session ID and the location of the MCP path, which is usually MCP/message. But the two things to remember here is that you have a session ID that you're then meant to use for the next request. So then, once you've created that session, the client then makes a request with a session ID, and so in this case, what the client is doing is trying to trigger a endpoint that will write a file to disk, which is nice and simple. And then the actual response will occur within the connection, the original connection that was left open. And that's where the return data comes back to. So if you're curious, this is this vulnerability is in a combination of Spring and Anthropic. It's actually within the Anthropic code base, but the Spring API, the Spring AI framework uses the Anthropic MCP on the back end. I originally found this. I first looked at Spring because Spring, but they went, no, not our problem. Talk to Anthropic. And this is what the kind of code looks like. Very simple. This allows you to write to a file on disk. The description is actually what's sent to the LLM for it to understand what that tool is meant to be able to do. So take a look at how this works. So this is perform using this MCP server. I'm going to be using Klein as my agent. This is a coding agent, like GitHub Copilot, if anyone's used that. Again, these are amazing kind of things, generally speaking. On the right-hand side, this is just a very basic MCP server written in Spring AI. Allows you to read, write, modify files on disk, which effectively any agent really has to have, because especially ones that might modify code. And this is how it's configured. MCP servers are configured. You have a list of tool endpoints, which is during the startup procedure, which I kind of skipped over. The MCP server returns a list of the tools and all that data to the client. So first of all, we're going to use the MCP server normally. Get a list of all the files under temp. Sometimes it fails. So anyway, yeah. So you can see the response, and you can see that we've got 3 files. So, what I said earlier, you need a session ID. You should need a session ID, I should say, because you shouldn't be able to trigger an endpoint if you haven't already got a session ID. However, in the vulnerable versions, one of the issues is you don't. If you don't give it a valid session ID, it just works anyway. So what we've done is trigger the endpoint. You may have missed that, what it does. So what that will have done is trigger the write file endpoint of the MCP server and put a file onto /temp. So what we can do now is, again, using the agent, run it ourselves. We should then see that there's a new file under temp, showing that we have actually, from the internet, been able to interact with an MCP server running on localhost. I can see that. I just realized I fat fingered it. But it worked it out anyway. And so that's the text that was written to the file by the JavaScript in the browser. So again, yeah, we reported this to Spring and Anthropic, and it was fixed. So using the later versions of Spring AI, you don't have this issue. They do now check the session ID. The other thing was the content type. This is JSON. They don't bother checking the content type. So yeah, it's one of those ones that usually with this, it needs to be quite sloppy coding in a few places for it to actually work. But especially with kind of like the gold rush with AI, I think a lot of the code early on wasn't necessarily, even in like big frameworks like Spring, and what Anthropic has written, weren't necessarily that good. But it's improving. Cool. So this is unfortunately an attack with a limited shelf life. There's been a few ways that browser manufacturers, especially Chrome, have been trying to fix it, and they've been trying for a while now. Originally, they created a spec called private network access, and it's designed to essentially block this kind of attack by stopping JavaScript running in the browser from, by default, being able to access localhost or systems on an internal network. This was meant to be in Chrome 101, which is a few years ago now. It kept getting pulled. I'll show you what it actually did. So, with private network access, before even a simple request, you would get a pre-flight request with this new header, and only if the server returned this header would the actual request be allowed through. That would effectively kill this kind of vulnerability, because who would do that? Unfortunately, the reason why it was tried in Chrome, then backed out, then tried in Chrome again and backed out, is because this broke a lot of stuff. There's lots of kind of, especially like web applications that were meant to run on localhost, and for some reason were to be interacted with other applications hosted on the internet, it would break them. And so, yeah, it caused lots of problems, which is why it was in like beta versions. It never actually got added by default. Yeah. So now the current status is this is what they're looking at. It's much simpler. So rather than the complexity of having all of the servers that require this to now add a header and check for the HTTP options request coming in and putting the header back, it's now up to the user. So when what will happen, this isn't on at the moment, is in Chrome at least, you'll get, if you have JavaScript that's accessing localhost or anything on your internal network, you'll get a prompt like this. And only then, once you click allow, will the original attack request to localhost or internal network will be allowed. So this will probably happen. This is much simpler and doesn't necessarily break functionality in the same way as the original kind of spec. And so this is the status of the current of the browsers. Not all browsers do this at all. So Chrome, local network access will be enabled at some point in the future. I'm not sure when. It was actually meant to go in September, and then it was pulled again. So who knows? It could just happen that, again, they have people complain too much, and it just stays off by default. Once it's in Chrome, it should go into like the downstream versions of Chromium, like Edge and the equivalent. Firefox have it on their backlog as well. IE no one cares about, and actually Safari never allowed this in the first place. Yeah, not sure why, but so yeah, it's as a attack vector, it's interesting. It may have had its day at some point relatively soon, but there are still quite a few issues like this around. In fact, so many kind of services bound to localhost, they don't bother with any kind of protections at all, and especially ones that are meant for developers usually have functionality that, as long as you can access them, you can get interesting things to occur. Yeah, there's plenty more. There's actually one Docker released a blog post on a MCP, not MCP servers, but an MCP inspector, which is like a locally run node app that interacts with MCP servers, so you can get data out of them and trigger them with like an AI agent, and that has effectively the same issue. You can run JavaScript on a third-party website. You'll interact with the inspector and then trigger the underlying tool endpoints. But yeah, I think that's about it. If anyone's interested, there is plenty of vulnerabilities like this to be found, for now at least. And yeah, all of the demos and payloads are available there at that link.
Thanks a lot. The localhost access seems to have some similarities to Travis Almendy's DNS rebinding type of attacks.
It's a similar issue, yeah. And when I talked to Anthropic, they said it's part of our spec. We should be stopping rebind attacks, and this is the same. And it's similar but rebind attacks are difficult to pull off in reality. Because you essentially have to be watching someone go to a web page, modify their DNS, and have them reload the page, or use JavaScript to reload the page, and then you can do stuff. With this, you just have JavaScript, and it does stuff. Yeah. And it's essentially completely invisible to the end user.
Yeah. Questions? Yeah, Eric?
That's really interesting for localhost, but have you tried the .local extension?
Sorry.
Have you tried the .local extension on multicast DNS that allow you to address a local system?
Sorry, I couldn't hear you.
Yes, you have. So you are attacking localhost via the code, but you can also access the internal network using the .local extension, which allow you to get the common name, like the modem always have the same name.
Oh, okay, yeah.
And then you can bounce on some common thing. Like you are in the US, you do Verizon.local, and Verizon.local, and then you get everything.
I didn't think of that. Yeah, that's, I've tried that. I haven't thought about that one.
Evil.
Yeah.
Anyone else? Or you're all heading for the coffee? Oh, we have a phone. Someone forgot a phone?
Sure. I guess you can just talk to me.
All right. Well, thanks, Joe.